Hey there, viewers. Welcome to the Repair It, Don't Wreck It channel. Today we're working on my good friend Artem 2008 Pontiac G5 GT. It has the big 2.4 liter gas engine. The AC was not working very well. After doing a few basic checks, I discovered the electric rad fan did not come on when the AC was turned on. The AC will not function properly until this problem is solved. Artem noticed that while driving at highway speeds one day, had to reduce the speed fairly quickly as lanes were closing for some road work. He got a message on the dash that the engine was close to overheating. However, temp dropped quickly, which indicates the high-speed fan was working. The first thing I wanted to do was check the fuse and the relay for the number one fan. There's only one fan that has a low speed and a high speed. The low speed number one cooling fan is protected with a 30 amp fuse. The speed is lowered by installing a resistor in series with the electric motor. While it is handy to have the information on the cover, the owner's manual is a great source for a picture of the fuse block, which you could print. I subscribed to all data for 1 month to gain access to all the drawings and data for this vehicle. They have a product for the do-it-yourselfer. Without the diagrams, it would have been much slower. I don't think I could have even figured it out totally. The colored wires and the numbers for the pins made it very easy to see what was going on. I removed the 30 amp fuse labeled cool fan on the cover to see if it was hot at all times. I wanted to check the fuse pins and make sure there was no other problems. With my test light, I've got the one lead on the negative connection just by the strut tower, and obviously the other lead was at the fuse connections. You could see that the light came on, so I know there was power to that point. The next thing I wanted to do was to remove the relay, also check the pins, look for corrosion or any abnormal things that may have happened. I wanted to also mark the relay so I knew what numbers were which. 30 and 87 are for the load, 85 and 86 are for the control, which connects to the module.
When I'm finished, I talk after.
Now that I put the fuse back in, I should have power at pin number 30, which I do. I made a single line sketch as to what is going on. This wire gets power from the power distribution block. It is hot at all times. It doesn't matter whether the ignition key is on or the vehicle is running. We're always going to have power to this fuse. This fuse protects cooling fan number one. The fuse is a 30 amp, and it's the low speed part of the fan. The next piece of the puzzle is the cooling fan number one relay. There are 4 terminals on this relay. You've got 30, 87, 85, and 86. And they're generally marked either on the back or on the side of the relay. The engine control module, it makes the decisions whether this fan comes on or not. By grounding that wire, current will flow through a coil in the relay, creating magnetism that will pull the switch closed. Therefore, 30 and 87 will allow power to go down the blue wire through the resistor, the cooling fan resistor, then down that yellow wire to the motor. Here's the resistor we took out of the vehicle. You can see that the drawing and the actual part are quite different, but after a while you get used to this. There's the two terminals where a blue wire and the yellow wire will connect to. Again, the power goes down the yellow wire, through the motor, and to ground. It's a real simple circuit. Now I'm going to test the relay. Probably you should look at some other videos that are dedicated to testing relays, but I'm going to do my best to show you what I'm doing. I have a power source and I've connected 12 volts to 85 and 86. When you do that, you're going to hear the relay click. Then I have connected my multimeter in the ohm setting between 30 and 87. So when the relay clicks shut, it should show some continuity. What you're seeing there is 0.3 ohms, which is the resistance of the wires themselves. If I take the power off, it goes to OL, overload, out of luck. Now when I put the power back on, you're going to see the 0.3 ohms of resistance. The next thing I'm going to do is to check the fuse. You can see the continuity there, and again, it's almost zero, but the wires have 0.2 to 0.3 ohms of resistance. When I take the leads off, it goes to OL. I am satisfied that the relay and the fuse are functioning properly. There are a couple other tests I can do, but after doing a little bit of research, I have found that the resistor is at the front of the engine and at the lowest point on the car. It's going to get a lot of water, and in the winter, salt water. I'm sure it's very rusted. Let's check that out next. After checking the resistor on the car, we found that there was no continuity, so I am quite confident there was a broken wire, and there was. So what you're seeing here is we've diagnosed a bad resistor, so we bought a new one. Here is the old one, and you can see when I get it at the right angle that the wire is broken. There may be some other things that are wrong with this vehicle, but we do know that this resistor is defective and needs to be changed. I ordered a part from GM. As with all electrical parts, I don't like to take a chance on aftermarket. There you can see the two terminals where the connector goes. Testing the resistor off the car is quite simple. On the car is another story. But what I ended up doing was putting two alligator clips, one on each side, so then I could attach my multimeter to it. In the frame, I've got the new resistor, and I'm going to test it for continuity, and I'm curious what the ohms reading will be. You can see that before I connect the meter leads together, that the meter shows OL. Now I'm going to test the resistance of the resistor in ohms, plus you're going to get the leads. So we're looking at 0.7, and I know the leads are around 0.3. So the resistor is probably between 0.4 to 0.5 ohms of resistance. Here I'm going to just test the wires for resistance, and you can see they're hovering between 0.3 and maybe 0.4. So you should always check that, especially when you're looking at small numbers here. Again, I'm checking the old one, OL, no continuity, so we've proven that this is a problem. At this point in the video, we know what the problem is. Since the car needed to be used, we took the rad fan out, checked the resistor, and ordered a new one. This took a couple of days, so we had to put the rad fan back in so that the car could be used. The good thing is we've removed some of the rusty bolts and done a dress rehearsal before doing this video. Whenever you lift a vehicle, always chalk the wheels to make sure the car doesn't move. Always lift the vehicle in as safe a way as possible, and always use jack stands to support it. Even though the underneath of the car looks rusty, it is not all that bad. If you take a small hammer and tap the areas of this subframe, it is as solid as a rock. We don't know the history of this car, but I believe it probably sat around for a little while and developed this rust, but it is not something to be too worried about. We did take out the bolts at the front of the rad support, and it was not all that tough. We got lucky where to remove the rad fan, it can come from below the car, so there's minimal parts to take off to get at it. On each side of the subframe, there's two brackets, and as you can see, I'm taking one out, and they support the condenser, the rad fan, and the radiator. You need to be careful when working under a car like this, as there's rust falling down all the time. At a minimum, wear eye protection. Even a small piece of rust could land you in the emergency room at a hospital. These bolts aren't too hard to get out. Don't forget, we've had this thing apart once already. It's a bit of a wiggle, push, pull type maneuver to get this bracket out. Here's another angle of what I just did. You kind of got to push up on the rad core support where the rubber bushing is and pull it out. I found when you twist it and then pull it out, it's the easiest way. One person could do this job, but definitely having a second set of hands makes it a lot easy. Also, having Artem there to do the videoing makes it possible. I couldn't imagine trying to do this job and video it at the same time. It would take forever. In the frame, I'm not worried about the weight of the rad and condenser hurting too much, but I am concerned that the transmission lines might start to leak, so I'm supporting it. This is the connector for the resistor. You can see the yellow and the green wire. Next, I'm removing the wire from the electric fan. There's a tab on it that you have to release, which we did, and it broke. Looking at the end of the connector, you could see that it is clean, and there's the red weather pack around, so there was no water intrusion. There's a small push connector to hold it from flopping around. Don't forget to remove that. And the wire colors on this are, here we come, yellow, and I believe they call it gray on the wiring diagram, and black. So yellow is one speed, gray is the other, and the black would be the ground. The fan basically will come straight below, again, wiggle, push, pull, and you can move the condenser and radiator towards the front of the car to give you more space. Now we have the fan on the bench, and we're going to check it out before we do other things. Here is the spot where the resistor goes in. As you can see, as I said before, it is at the worst place in the car. Very low and exposed. One little test you can do while the fan's on the car is to spin the fan. If it doesn't move at all and it's jammed, you're definitely on the right track. Here are the 3 pins on the fan: high speed, low speed, and ground. So here I have one of my leads I'm connecting to the high speed, and the other lead I'm connecting to the ground. Make sure you get the alligator clips on tight and in the right spot. You can see I have to wiggle it with it a bit to get it just where I need it. Also, ensure that they're not touching each other or anything is touching the center terminal. So to recap, the red wire is on the low speed, and the wire without any markings on it is to the ground. At the car, there's a negative post, shall we say, at the strut tower, and a positive. The fan's working just fine. Listening to the fan, it sounds pretty good. I don't hear anything that sounds out of the ordinary. From what I've read, these fans are fairly durable. I'm not sure if there's bearings in it because they are a DC motor, but if there is, they're very quiet. Now that the connections are made, the routine is the same. Negative to the negative post, positive to the positive post. The fan is working perfect. On this car, the battery is in the trunk, so that's why they put these posts up at the front. Now that we've checked out the fan, we can install a resistor. It's a fairly straightforward job. One bolt that goes into the plastic, so be careful. You don't have to over tighten it. And half of the bolt will capture the resistor so it stays in place. I'm using a 1/4-inch ratchet here so it helps me from not overdoing it. Just a little crank and that's all you need. The fan will go in the same way it came out, through the bottom, and having that extra set of hands to help move things around is a bonus. You can see where I put some lubricant, that white lithium grease, and that's to help slide it back into place. And then in a second, you're going to see the second part of the bracket that keeps the fan in place with lithium grease on it. Those two brackets on each side is what holds it in against the radiator core. Definitely having two people for this part of the job is a real bonus. We're trying to show the other side here, but there's so much stuff in the way we really can't get the camera to focus. But I think you get the gist of it. With the bracket lined up, you can install the bolts. Make sure they go in by hand first, a few threads, and then you can snug them up with either a ratchet or an air wrench. Here's some video when I was doing the bracket on the other side, and I'm showing you just snugging these bolts up. This video is more of a informative video showing how to do things. It's not one of those videos where we film it from beginning to end with no editing and no breaks in the action. If I did it from beginning to end, the video would be 2 hours long. I'm not a professional. I'm a guy who likes to work on cars and learn stuff. So this way I can pass along what I've learned and keep it as short as possible. Before I forget, we did test the fan, turned on the air conditioning, and everything works perfectly. So it was a simple repair as changing the resistor. We're approaching the end of this project. All the black plastic clips that hold the air dam on were replaced. We found it was easier just to order a box of them off of Amazon of different sizes. These ones are perfect. They're snug enough that they'll stay in, but not so big that you can't get them in. When you do this, it just shows you care about the project. All the clips are replaced. We took the effort to go find some replacement parts and not put the old stuff back in that would probably fail. It was a lot of fun having Artem help out and also do the videoing. I hope you liked the video. Please give me a thumbs up. Subscribe to my channel. And as always, repair it. Don't wreck it. Thanks for watching.